Good evening, everyone. My name is Nicole Milano, and I'm the head of the Medical Center Archives at New York Presbyterian, Weill Cornell Medicine. I want to thank you all for joining us for the joint Heberden Society Division of Medical Ethics lecture of the 2021-2022 academic year with Dr. Howard Markel. Now, before we hear from our speaker today, I do have a few announcements I want to make. The first is that I would invite you to join us for the remaining two Heberden Society lectures this academic year. On March 30th, Dr. Susan Clark-Ball, who serves as Assistant Director of the Burnbound Unit at the Center for Special Studies at New York Presbyterian Hospital, will be reflecting on her work in combating the AIDS crisis, 40 years after the identification of the first cases of what would later become known as AIDS. Finally, Dr. Keith Waylu pulls back the curtain to reveal the hidden persuaders who shaped menthol cigarette buying habits in racial markets across America on April 27th. I will be sending out more information regarding registration following tonight's lecture. Now, if you're interested in the history of the New York Presbyterian Weill Cornell Medical Center, I would invite you to explore the website for our very own Medical Center archives. The archives includes photographs and documents dating back to 1771, including this photograph from 1951. Now, thousands of photographs and documents are digitized and available for reference through the link seen here. Now, we would invite you to participate in our Q&A following tonight's lecture. So you'll see a box at the bottom of your screen where you can enter a question, and we'll get to as many as possible at the end of the lecture. Now, on that note, I'll turn the virtual microphone over to a fellow member of the Heberden Society and our co-sponsor for tonight's lecture, the E. William Davis Jr., ND, Professor of Medical Ethics and Chief of the Division of Medical Ethics at Weill Cornell Medicine, Dr. Joseph Finns, who will introduce our speaker this evening.
Thank you, Nicole, and I wanted to also welcome you back after having delivered a wonderful little boy 8 weeks ago today. It's his birthday, Mateo. So congratulations on the new addition to the Weill Cornell family. And we're really honored and pleased you're back with us, and congratulations. I'm really thrilled to introduce my friend Howard Markel. We were saying before this started that we knew each other, former younger selves, and we did. And it's been a true pleasure to watch Howard's career. His arc has been just stellar. He's been described as perhaps America's greatest historian of medicine. He's trained in the history of medicine. He went to Michigan for college and medical school, then his residency and fellowship in pediatrics at Johns Hopkins, where he also got a PhD in the history of medicine. He's written a whole host of books, most notably recently the book Quarantine. He's been a consultant to the NIH on pandemic flus and the like. There's not any aspect of the history of medicine he hasn't touched with great elan and skill and nobility. He's a wonderful writer, really thoughtful guy, and he's funny as well. And we're honored today to have him speaking about the secret of life and the early history of the discovery of DNA and the cast of characters that made that possible. And he has some untold history to share with us. So without further ado, Howard, welcome to Weill Cornell, and thank you so much for gracing us with your erudition and your presence.
Oh my, thank you, Joe. How do I respond to that? That's going to be hard to top. Thank you so much. That was very nice, and I'm delighted to be here. I was saying before, my daughter was born at New York Hospital in, I think, the Greenberg Pavilion, if I'm not mistaken, and I've been to New York Hospital many times, but not lately. So I'm very touched and honored to be part of this. Today, I'm going to be talking about my latest book called The Secret of Life, Rosalyn Franklin, James Watson, and the discovery of DNA's double helix. And I came to this project having taught a course for my medical students called Great Papers. And I always wanted to do this, and I had a whole bunch of MD PhD students who were really eager to do this, and I served them lunch. But the first paper we did was the 893 word paper in Nature on April 28th, 1953, of Watson and Crick's model. There's not a scintilla of data in that, by the way. It is all hypothetical. And about 75 medical students came, and they're all eager to do this. So I thought, well, something is going on here. And I have two daughters who have a lot of opinions and know a great deal more than their father, so they think. And they said, well, you got to write about Rosalyn Franklin. And I said, well, I remember reading the Double Helix as a young man. I think I was about 18. I got it my first or second term of college. And I still have that edition back there somewhere. And if you read the Double Helix, and I'll talk about that, it's not a generous book. And Rosalyn Franklin is really demonized and treated very badly, even though the afterword says, I may have overreacted, she was okay, but well, then why tell the story in that manner? But my kids want to say, well, what about Rosalyn Franklin? And I said, well, you know what? I don't know what happened. But what a historian would do is dig in, find the usual, round up the usual suspects like they do in Casablanca, and you go to those people's papers. While you go there, you talk to other archivists or librarians or what have you to say, oh, you might want to go here or there. And so you go on this path. We were talking about how does a historian work? It's like, well, the first several places to go, but it's amazing when you discover something by accident. So the American Philosophical Society was right across the street from a hotel I was staying with my daughter. My oldest daughter goes to Swarthmore in Philadelphia, or outside Philadelphia. It's right across the street. So I went there. Not only did I find what I knew I was going to find and had to find, but the archivist said, "Hey, look at I'll show you what I found there." So it was just this incredible journey, if you will. And I'd like to take you through it. Let me share the screen here. Start with the slides. Okay, so you're gonna. Okay, so that's just the advertisement. Now, the dramatist personae. Who's there? Who's who? We have 5 really key people, and most of them, at least 4 of them, are under 40. At King's College, we have Rosalyn Franklin and Maurice Wilkins. The Brits pronounce Maurice Morris. That's King's College, University of London, right off the Strand. And at Cambridge, you have a 22-year-old postdoc, PhD wonder kid, James Watson, who is, by all accounts, DNA crazy. And Francis Crick, who's about 36, he's the oldest of the group. He's about a year older than Wilkins. And he's a permanent grad student. He just cannot finish his PhD. And in fact, a year before they wrote their paper on DNA, Lawrence Bragg, the head of the lab at Cambridge University, at the Cavendish lab, wanted to throw Crick out because he was so dilly-dally in his doctoral work. And the senior person, who was actually in his 40s, was Linus Pauling at Caltech, who was not only a quantum chemist, but he had studied the structures and shapes and planes of bonds and how that will alter the way a molecule looks. So it's really molecular biology and molecular chemistry at its birth. He was considered, by all accounts, the smartest and best chemist in the world. And in fact, in 1955, he won his first Nobel Prize for chemistry. Of course, I mentioned the double helix. He had to put a lot of his colleagues, including Francis Crick and Maurice Wilkins, wanted the book squashed. It was originally going to be published by Harvard University Press, and they wrote a whole slew of British scientists wrote letters to the president of Harvard. And the president of university rarely, if ever, interferes with its university press. This one did. Nathan Pusey called the head of Harvard Press, and they canceled it. But the editor at Harvard Press, who had accepted the book, had just taken a new job in New York at Athenaeum, which was a new nonfiction press in the 60s. And Double Helix became, a bestseller. There's more than 1 million copies in print. And by doing it, it's a short book. It's really like 150 pages, so it moves really fast. There's a lot more science in my book than in his book, and he's a scientist. But he really commandeered history, because he told his story first in a very telling and powerful way. I mean, you can say a lot of things about Jim Watson, but he knows how to write a book and he knows how to tell a story. And that's a fascinating concept, by the way, is how people can shape history, or at least the memory of history, based on how they tell that story. And how long does that change or allegiance to what really happened last? By the way, Watson and Crick didn't discover DNA. DNA is a chemical. It was discovered by Friedrich Miescher, a Swiss physiologist, who would drain surgical bandages that were filled with pus, and the white blood cells that came out were just perfect for drawing out DNA from the big nuclei. And he called it nuclein. That was the original name of DNA in 1869. It's a nucleic acid. Now, Erwin Schrödinger, you may know as the Nobel Prize winner for physics, and also Schrödinger's cat, but he wrote a book, a really thin book. It's actually a series of lectures he gave in Dublin called What is Life? And he's hypothesizing in this book the notion that if you have quantum physics with atoms reacting, and quantum chemistry and molecular biology, then we probably ought to be able to break down the chromosome, which they knew about, into a gene, into some genetic material. And that was a really phenomenal book to a lot of people. Morris Wilkins read it, and he was a solid state physicist who decided to go into biophysics. Crick read it. He was working for the Admiralty on mines during the war, and he decided to go into biophysics. Watson read it, changed his world, he said. We know that Rosalyn Franklin probably read it, but we don't have her response. And Linus Pauling thought it was a lot of hogwash. Nonetheless, it was an influential book that got a lot of people to think about the notion that there is a tiny, but unbreakable unit, if you will. They can be mutated, but a unit that guides heredity. This is John Randall. He ran the biophysics lab at King's College, University of London. He was a very dapper dresser. He was a bad manager. He was bossy and domineering. He liked to get his name on papers. He was also horrible telling employees what they should do. And he told Rosalyn Franklin when he hired her to help Morris Wilkins, who was not a X-ray crystallographer. She was one of the best in the world. So he really couldn't do that work. So when she was brought in, Wilkins assumed she was his assistant. You know, this woman, she's my assistant. Well, she disavowed him of that quite quickly. Rosalyn Franklin was a fascinating woman, by the way. I'll get to her, but she didn't suffer fools gladly. And of course, the first letter, her first offer letter, I found that was not to look at DNA at all. It was to look at colloid proteins in solution. And he changed it when she visited the lab just a few weeks before joining it, and when Wilkins was on vacation. So this is like the most colossal snafu in human relations in the history of science, to put Rosalind Franklin and Morris Wilkins together. They just hated each other. This is the quad right off the Strand where they worked. They actually worked in the basement of this building. There was a giant bomb crater right where, in front of those benches, when they were going to school there, or they were working there as a result of the Blitzkrieg. This is actually where Rosalyn Franklin worked, and where it says King's College, London, Photonics and Nanotechnology. That was, in Morris Wilkins' words, Rosalyn's pokey little room. And that's where she did a lot of her work. And that's probably where Watson interrupted her when she was looking at her slides or her X-ray crystallography data, and he rushed in to tell her about Linus Pauling's paper. Here we are. I actually call it the biggest human resources snafu in history of science. There's some very fascinating oral histories in a variety of places that have been done over the years. And a lot of people, Crick, Drew worked at Cambridge. There was one other, Linus Pauling's son, Peter. They all thought that Wilkins had feelings in some way for Roslyn. He was incredibly bad at dealing with women. He writes in his memoirs how twice as a young man, he lost girls by taking them out and saying, "I love you," without ever sitting next to them, or just being very awkward. And he just had a lot of problems with women. And he also, when he talked to women, he would turn his body around like I'm doing right now, so he didn't have to make eye contact. So he was just a weird guy. And he had a very, old style chauvinistic way. And Rosalind was incredibly bright and incredibly adept at the mechanics of moving this bulky X-ray camera that has like basically a tungsten wire on either end and a stretchy fiber of DNA between it. And she's photographing this in multiple angles and in multiple shots, each time putting a new photographic plate, because the X-rays she's beaming at it bounce off the atoms of the molecule. And from looking at that diffraction pattern and a lot of math, believe me, more math than I'm capable of, you can figure out its structure. And so she was, she went to Paris to train for this. She was a Cambridge PhD, and she was a very strong personality. Now, to people who loved her and liked her, she was funny, she was pleasant, she was a good daughter, et cetera, et cetera. But there was just some people who found her very abrupt or brusque. It's interesting because everybody in this story is kind of weird. Okay, everybody's got their own set of issues, as my daughter would say. Okay, but it's Rosalyn Franklin's issues that matter the most when they're kind of going against her. She also had, beyond being one of the few women in physical sciences in Britain, she was also Jewish. And I found this very interesting. George Orwell wrote an essay in the Anglo-Jewish Chronicle in 1948, 1949, and he said, ironically, there's more anti-Semitism in Great Britain now than before or during the war. That's quite striking because that's about the time, 48, when news of the Holocaust is becoming quite widespread. So that I find that very interesting. But she had a couple of strikes against her because it was very much a male-dominated society. And of course, this is such high-powered physics, biophysics. Almost everybody in this group eventually is going to get a Nobel Prize or something. These are really, really important people. Here, we were talking about the Naples Zoological Station. I spent some time there research. Watson was a postdoc in Copenhagen working for a man named Herman Kalkar. And Kalkar was going to take him down to Naples for a lecture that John Randall, or a conference that John Randall was supposed to present at. What Kalkar didn't tell Watson is that he was also inviting a 20-year-old graduate student named Barbara Wright, and he had a villa for him and Barbara Wright, and Watson was his beard. What happened a little bit after, besides that romance, is that Watson met Wilkins, who was giving a lecture that Randall was supposed to give, but in his stead. And Wilkins was delighted because at the Naples Zoological Station, the Bay of Naples is so rich in aquatic life, they can get almost anything you want. And they have fishermen that go out every day. And he was working with sepia squid because their sperm cells had unusually large nuclei, and it was easier to draw out DNA. Well, one of the side trips of this conference was they went to Paestum. And Paestum is probably the best preserved Greek temples, maybe certainly the best out of Greece. And they're just remarkable. And at one of these temples, Watson found Wilkins, and he had his sister with him. He had his sister with him, and he tried to introduce his sister, thinking that Wilkins would take her out, and then he could get a job as a postdoc at the King's College. And Wilkins wanted nothing to do with it. Watson just sulked. And then he decided he would have to go to Cambridge, which was the only other place that was doing X-ray crystallography on organic, living molecules. This is what I found thanks to an archivist. I didn't find an archivist said you should look at this. And this was at the American Philosophical Society. And I was looking at a completely different set of papers. A man named Horace Judson, who was a New Yorker writer, who interviewed a great many of these people and wrote a book about it. But this is from Erwin Chargaff's papers. Remember Chargaff's rules? A equals T, C equals G. And he's the biochemist at Columbia that came up with this. He was an emigre from Vienna. and of course was Jewish and left just before the outbreak of the war. But in this letter that Wilkins is writing to Chargaff in January of 1952, you can see on the left side, there's a drawing that looks like a cross. You see that X? There's two of them. Okay, that's the zigzag or the Maltese cross that we're going to see again. And then on the right side, you see there's a spiral. It's not a double helix, but there's a spiral, and the nitrogen bases are in the center, which is not far off. So both Erwin Chargaff and Morris Wilkins have this information right there in front of us a year before Watson and Crick figured out, and they can't figure it out. That's important. As Watson told me, you don't get the Nobel Prize for not being able to figure out your own data. And I asked, shouldn't Rosalyn Franklin have gotten a piece? And then I said, but wait a minute, Morris Wilkins couldn't interpret the data either. To which he replied, yeah, but we all liked Morris. Do with that what you will. Here's Cambridge University, where he went, where I'm supposed to be. I hope to be there in a few weeks. And he worked for Lawrence Bragg at the Cavendish Laboratory. And Bragg was one of the co-discoverers of X-ray crystallography with his father, the only father-son team to win the Nobel Prize. And they started doing it on simple inorganic molecules, which are much easier to measure, like sodium chloride, than a protein like insulin or something like that. But they kept using this beam. So Cavendish had a long history of doing work like this. And here's the Cavendish Laboratory, the older part on the left, and the Austin wing on the right. And I was lucky to get into the Austin wing just a few weeks before it was being ripped down, because that's where Watson and Crick had a room. And it was, well, if you can see the door on the right, near that car, there's like a door, and you go up one and then go over one. That was their office. I'll show you a picture of it in a moment. Here it is. And I found it hilarious that it was storing skeletons for the zoology department at the time. But that was, and you can see how it looks with that person working there. That's almost exactly how it looked. It was, there was 4 desks and shelves and stuff like that. It was a room, and they were theoretical physicists. That's what they did, a blackboard or pencil and paper. Now below are 2 people, and there it is, room 103 up there. You can see it. On the left is Peter Pauling, a ne'er-do-well son of Linus Pauling, who's sent to Cambridge University to mature and season up, and he works in the Cavendish, and then he's assigned the same office as Watson and Crick. Now, Watson and Crick were given an office because they were so loud and noisy, they gave them the office way on the end because nobody wanted to deal with them. And then the guy on the right is Jerry Donahue, and he becomes very important. He also shares an office because he worked for Pauling, and he knew that the isomers that Watson was using to try to build his model were wrong. We'll get into that in a moment. Here's Watson and Crick on the backs. There's King's College right behind them. They took walks every day. Here they are, just a little close up in the entire Department of Physics, which was an enormous department of about 150 people. Here's Linus Pauling, who also won another Nobel Prize for his peace work. And so he was very much a peace activist against nukes, against war, against the Vietnam War. But he also was an incredible chemist who figured out the the alpha helix and the beta pleat of amino acids. So that was pretty good. But he also was working on a model, and he actually sent the proofs of this paper, which were in PNAS, the Proceedings of the National Academy of Sciences. He sent the proofs, or a preprint, if you will, to his son, Peter. Peter walked in room 3, and he kind of let it out that he had the print. Watson literally grabbed it out of his hands. And now Watson, there are a few people in the world who could look at that model and were that at one with DNA, even though they didn't know much about it. I mean, it's easy now because we know how the parts fit together, but imagine when you don't know, you only know half the parts. But they could see from this model, which was a triple helix, it didn't tell you anything about replication, okay, for one. And two, this triple helix is not an acid. It doesn't have an H+ ion. And what is DNA but a nucleic acid? So they laughed and giggled and they ran to the organic chemistry department. Yep, nucleic acids are acids. They ran to, but they also knew that this blooper, which anyone could see if they were, in tune with chemistry, was only going to last 5, 6, 7 weeks, depending on when this paper got published. So if Watson and Crick were going to do anything, or Wilkins and Franklin for that matter, they better act quick. Well, this was the paper that Watson brought first to Wilkins, and he said, I'm busy. And then he rushed in on Rosalyn Franklin. She's here at Montalcino. I know that wall well. I have hung on that wall. She was an intrepid traveler, mountain climber. Here she is at a mountain climbing trip. She spoke French fluently and of course lived in Paris for 4 years, loved it. And she came from a very, very prominent Anglo-Jewish family. Her great uncle wrote the Balfour Declaration, or the original draft for it. She had another uncle who was Attorney General in Palestine, mandated Palestine. And her family were bankers and publishers and part of the, our crowd, if you will, of Anglo Jewry or British Jewry. This is Jennifer and Ian Glynn. Ian is on the left and Jennifer is Roslyn Franklin's sister. And she's now 92. I just got an email from her yesterday because I'm supposed to be there and I want to give her a copy of the book myself. And so I really learned a great deal about Rosalind through Jennifer. Here's where she lived. I really traced her down. This is in South Kensington in London. I even when somebody buzzed, I got up to her floor, but I couldn't get to her. I couldn't get into her apartment. That's another crazy thing that historians do, by the way, is that they track where people live. Here she is looking through a scope, but she used to also have an attachment, a microscope attached to a light box, because she's looking at little tiny smudges. It's really intense work. And they're, the differences of dimension between the two that she has to measure is also very hard. So imagine you're the type of researcher, and I'll bet half of you in this room are. I know I am. When you are working really hard on a particular intellectual problem, it doesn't matter if it's at the lab bench or you're reading, and you're in a little safe space, and somebody walks in, and it's very jarring. It can be very, very upsetting to a lot of people. I know I find that way. And Rosalind was one of these people. And when Watson came in her lab, she basically, get out of here. She thought he was a butterfly, like this flibberty gibbet guy. He never did any data, and he was young. And then he talked down to her, and he basically said, you don't know anything about the helixes or DNA. And this is where the big story is. She got up, this 5'2", 120-pound woman. She got up, and Watson was 6'2" and thin, but 6'2". And I felt she was going to strike me. Later on, Wilkins said, well, I'm not sure anybody was going to get struck, but tensions were high. I asked Watson when he was 90 years old, and he said with full conviction, oh yeah, I really thought she was going to strike me. But the notion of a small person striking somebody, I asked Jennifer about this, and she said, Rosalind would never strike anyone. That's silly. And that's the problem, by the way, with the Double Helix. As great of a fun of a book as it is, a lot of its critics have called it a novel, and that's part of it. So she threw him out, and then Watson went into Wilkins's office, and he showed her all of Rosalind's work. Rosalind, by this time, she had been iced out, frozen out. So she decided to leave to go to Birkbeck College, where there was a guy named J.D. Bernal, who was a very major X-ray crystallographer, which she did. But do you see this X? Does it look familiar to you? Does it look like that drawing I just showed you? But when Watson saw it, it's a double helix. And as he said many times, once I saw it, I couldn't unsee it. Here's the ethical thing, and I'm glad that Joe is here. And I'm trying to look at, what the ethical conduct for research is and so on. At the time, as now, if you're a postdoctoral fellow and you're leaving the lab, your data goes to the PI, the principal investigator on that grant, because it's the property of that. So it should have gone to Randall. Now, she was so disgusted with the whole lab and didn't even talk to Wilkins for months. It's hard to know what happened. One of her students, a guy named Ray Gosling, said she handed it to him and handed the pictures to him and told him to give it to Wilkins. Another time, Gosling says, I don't know how I got it. The point is that she was right down the hall, maybe 400 feet. You saw that hallway that I showed you, when he decided to open a drawer and show Watson, who was known to be DNA crazy and was known to be a competitor, her pictures. There's no planet where that's allowable, because she was right down the hall and he could have simply said, can I show Watson your pictures? It would have been the decent thing to do. That was the first of many things. Another thing that was really problematic was Max Perutz showed Crick Rosalyn Franklin's interim progress report, which Perutz got it because he ran a biophysics lab under the Medical Research Council, and the various directors got this. But to hand that to somebody who is DNA crazy and a direct competitor. In fact, Bragg banned Watson and Crick from doing DNA research from 1952 to 53 because they built some crazy model, a triple helix no less, and got everybody pissed off, particularly the King's College group, because that was their job, that was their lane. So, it's very ethically problematic, but there was also a conspiracy of sorts, because nobody talked about it and nobody presented it until many, many years later. And even on the famous paper, this is the Eagle Pub, but the DNA paper, even the way they acknowledge Rosalyn Franklin, they say we did not know about any of her work, we didn't see her pictures, and I mean they go overboard in saying this all came out of their minds. But of course it came from both photograph number 51 and the interim report, which alerted Crick that there was anti-complementarity, this goes from the start to finish, and this is the opposite, but also how the double helix would work. This is the Eagle Pub where they used to go. It's literally 100 steps from the Cavendish, and that's where they would tuck into their bangers and mash or whatever they would eat. Here they are in room 103. You can see the similarities. This is after they announced their paper, and they feel very good about their success. And here they are posing with what Wilkins always called the WC model, the water closet model. Here it is, the paper. We have also been stimulated by a knowledge of the general nature of the unpublished experimental results and ideas of Dr. M.H.F. Wilkins, Dr. R.E. Franklin, and their coworkers. But what it says on the next page is that we didn't see any of their data. Now, sadly, Rosalyn Franklin died of ovarian cancer at the age of 37. When you think of the amount of X-rays that she was exposed to, because she was really known to be really in there with this machine to get the shots that she needed. And of course, no one wore badges back then and got it measured. I mean, the amount of radiation could have caused her ovarian cancer. She could have had the BRCA1 or 2 gene, but nonetheless, she died tragically at 37. And at that time, she was working on viruses, particularly poliovirus. And so her epitaph says her research and discoveries on viruses remain of lasting benefit to mankind. She died not knowing that it was her work that really opened the open sesame, if you will, to DNA. Everybody I interviewed or looked at their oral histories have said that. When I talked to Jennifer Glynn, she looked at me, oh, there's no question she knew nothing about it, because if she did, there'd be a terrible row. And it would have been fierce. And so when I asked her about the epitaph, she said, well, that was what she was known at when she died. And that's historically correct. Jennifer actually is a historian. And that's how we'll leave it. So, she this blue plaque, you may have seen blue plaques if you've gone to London, is outside her house in South Kensington, but it says that about the importance of a pioneer in the study of molecular structures, including DNA. Now, the Nobel Prize went for medicine or physiology in 1962 to Watson, Crick, and Wilkins. Ironically, the prize for chemistry went to John Kendrew and Max Perutz. They're on the left, and they were the supervisors of Watson and Crick. And the other guy who won it for literature was John Steinbeck, who was a big, both Watson and Wilkins were big fans of John Steinbeck's work. And so getting into the Nobel Prize archive was quite difficult. It was probably the most difficult archive I've ever tried, because it's not an archive, it's not a working archive. It's the archives they have are for the people who are on the committee, so they can look up, for example, somebody who was nominated last year, and they'd have a dossier and you could bring it back to this year. And in fact, you can't look at anything that's not older than 50 years, but of course this is. And I got it finally in a day. You could come on June 22nd, 19, just before, 6 months for the pandemic, so I guess it was 19. And I flew to Stockholm and went through there. And what was fascinating, it's a couple of things. One, most of you all know probably, you can't win the Nobel Prize if you are dead. It's just the rule. It's just the rule in the will. Also, more than 3 people can't share the same prize. Again, just in the will. When I said to Watson, because I spent a week with him interviewing him, what if you guys won medicine or physiology and she and Wilkins won it for physics or whatever? And that's when he stood up and said, the last time I checked, you don't win the prize for not being able to interpret your data. But anyway, in those files is a dossier on Watson and Crick, and by a very good crystallographer named Arne Westergren. And he said, well, I'm hesitant to give the Nobel Prize to 2 guys who didn't do any laboratory work. They just, and then if we were going to do the laboratory work as well, there are 2 schools. There's Wilkins and his group and Rosalyn Franklin. Now, she passed away, but had she been alive, she might have, or she would have had a claim to this Nobel Prize. So that I found really fascinating and vindicating. People say, why didn't you win the Nobel Prize? And the rules are arcane and not very satisfying when you explain that to somebody. But when you learn that at least the committee, if not the nominators, and if not the nominees who never mentioned during their speeches, at least the committee mentioned her. But that was behind closed doors, of course. Here again is Watson and Crick and Wilkins. And there's Watson getting his Nobel Prize. I love this. Morris Wilkins spent the rest of his life trying to explain the way he treated Rosalyn Franklin. It got worse every year. And as Jennifer Glenn said, it must be terribly hard being that man. He's all knotted up like a pretzel. And I love the fact that he called his book, his autobiography, The Third Man of the Double Helix. Or a movie buff, there's a wonderful black and white film called The Third Man with Orson Welles. And in the beginning, a man dies in the street and 3 people pick him up to take him away, but nobody knows who the third man is. And so this is the title of his autobiography. It's kind of sad to put that on your memoir. You're like 0. Or so here's Cold Spring Harbor. It's interesting because it was originally the Eugenics Records Office, which was where a great many issues regarding sterilization, which race is better, etc. In the middle, that was Charles Davenport, the head of the ERO's home. It's now a dormitory for the Cold Spring Harbor Laboratory School of Biological Sciences, which was formerly called the James Watson School of Sciences. And it's now a major molecular biology and cancer research center. And a lot of that is thanks to James Watson, who built this from basically a summer camp for geneticists, which it was on a beautiful harbor, into a remarkable laboratory. And this is James Watson at 90 in his office. His Nobel Prize is behind there. And he was a very interesting fellow. We can talk about him. He was certainly the most major figure I've ever interviewed. And I'm not going to tell you what happens at the end of the book, because I said this on PBS NewsHour. They asked me about the end of the book, and I said, well, it held me to the edge of my seat, and I hope it'll hold you to the edge of your seat too. So I won't declare that just yet. But there's Jim Watson, who was really very helpful. And I'll take questions if is that good? I can talk longer.
Well, that's wonderful, and I hope everybody goes and gets the book. And I want to just thank you, Howard, for it was scintillating, and you took us on that journey. And I just want to remind everybody that if you have questions, please put them in the Q&A, and we don't have any yet, so your opportunity is wide open. I will ask the first question.
No waiting.
No waiting. It's perfect. So, and even the first person will be the third man. You can just come right in. Now, I want to ask you a question, Howard, about the uses of history. Obviously, you wrote this book with a purpose to give truth to the story, and we're re-examining our past in many ways, and we're reconfiguring a lot of our conventions and taking down statues and all that. And you mentioned that the Nobel Rules are very arcane. Do you think an exception should be made for Rosalyn Franklin, and should that be revisited?
If I were running the Nobel Prize, I can see why they wouldn't, because that would open up probably 20 other people with similar claims, this past year. You know what I mean? That's a problem. I do, on the other hand, feel that I'm not beyond saying certain things should be revoked. And this is not a Me Too moment. This is a Me One moment. And this is the way women are routinely treated in the workplace, but certainly in the ivory towers that we all love and have dedicated our lives to. And of course, they were run differently and not in a way that we would feel comfortable or our colleagues would like to work under. So, even the title, The Secret of Life, okay. Watson claimed, Crick said, the secret of life. We have discovered the secret of life when they walked into the Eagle pub after figuring it out. Crick says, I never said we did. That's not something I would say. That doesn't even, that. Watson finally admitted, like 50 years later, at a special celebration of Francis Crick, he never said it, but I wrote it. When I asked him about, well, he didn't say it, but he should have said it, and he would have said it, and everyone believed he said it. So he had a great idea. I mean, he had a notion of what he wanted his characters to do. And of course, he had to have a villain. And the first villain was Rosalyn Franklin, or Rosie, which was a name that she hated. No one called her Rosie. And Linus Pauling, in a way, should have kind of been there if you needed that kind of protagonist, antagonist. But he was too important to hate at that time. But I just wanted to bear witness to see what happened. And so anyway, back to The Secret of Life. The reason why I call the book The Secret of Life is that the story depends on who tells it. Me too, me included, by the way, but I hope I'm a little bit more judicious. But there are uses of history and ways of layering on stories that aren't, they're stories, they're not necessarily facts. And, I know there's a common parlance now, I think it came out of Hamilton maybe, but everyone has their own truth. Well, everyone has their own version. Truth is elusive and may be impossible to really reach, but it's a very hard mountain to climb. We all have our versions. Then we have to figure out what actually happened.
Okay, we have a few questions have come in now. Which of the Franklin products were more valuable to Watson and Crick, the Crystallograph or the annual report given by Peretz to Watson and Crick?
It's a great question. They were each important to the individuals. So for Watson, when he saw photograph 51, he debating whether it was helical or not, because DNA has two forms, a dry form and a wet form. The wet form actually was easier to see the helix, but the dry form, there were a lot of artifacts. And Rosalind kept saying, we can't say it's helical till we get every last detail. She was that kind of a scientist. So for Watson, it was clear to him that it was helical, and he felt mystically, because things come in pairs in biology, that it was a double helix, but it could have been a triple helix, he thought. Crick, on the other hand, when he read these, it was about a 5 or 6 paragraph interim report, but it has real numbers and real measurements and meridional arcs and all this kind of stuff that you need. And that, to him, it wasn't only a double helix, he could figure out the arc and how many times it revolved around it. And so Crick had the kind of spatial mind that was just beyond the rest of us. You know, he could see these 3-dimensional things.
So there's a parenthetical comment here. Ralph Steinman was awarded a Nobel Prize after his death.
Say this again.
Ralph Steinman was awarded a Nobel
Right.
Prize,
Right, because he died between the days that it was
Right.
awarded and he died, and that was a particular asterisk. And Dag Hammarskjöld got it after he died. He got the Peace Prize, I forget what year, but he died in an airplane crash. They now have a specific rule that I think you have to be alive to actually come and get it, I think.
Right, but you don't have to show up. There's Bob Dylan.
Yeah, that was weird. That was weird.
We have
On so many levels.
It's so many levels. But I thought he was deserving.
A lot of my friends do too, but I'm a Philip Roth fan, and he's gone.
Well,
now.
yeah, of course, another one. So that's your next book.
Yeah.
Here's another comment.
There was one that got canceled.
Oh, it got canceled. Okay, the story reminds me of another troubled scientific team of 100 years ago, the Insulin guys.
Yes.
Question, there was a good production of the play, Photograph 51 in Philadelphia a few years ago. I wonder if you've seen it, and what did you think of it?
I like it. Anna Zigler is the playwright. Saw it with Nicole Kidman in London as Rosalyn Franklin. You know, I mean, of course it's dramatized. There are things there. She has a relationship between Don Casper and Rosalyn Franklin, which may or not had a romantic relationship. He was an American biophysicist who trained both at Cambridge and at, I think, UC Berkeley. But I like the play.
So I'm gonna, there's a question here from Joydeep Mitra asking about your comments on Watson's interview in 2007. The scientist who once worked at Cambridge's Cavendish Laboratory told the Times newspaper that he was, quote, inherently gloomy about the prospect of Africa, close quote, because, quote, all of our social policies are based on the fact that their intelligence is the same as ours, whereas all the testing says not really. So can you comment on his view of genetics and eugenics and the like?
Well, it's a very unfortunate part of his character. And what you didn't quote was the line after that he was quoted in the London Times when he said that, which was this: if he didn't put enough knives into it, and anyone who has employed an African-American would know what I mean. So he just went downhill instantly. He was on a book tour. The book tour was Avoid Boring People.
Right.
And he was going to do all these important places in England and Ireland, and everybody canceled, of course. I have letters quoted in the book where he's a very young man and he's saying terrible things about Negro neighborhoods, because of, you know, or Jews and Italians who live in Brooklyn. I suspect it was normative, not normal, but normative in his household for the parents or relatives to use these terms and characterizations about other people of other ethnicities. And when he said what he said, of course, that was hugely problematic, but it gets worse. Because only a week before I got to Cold Spring Harbor in July of 18, he had done a series of interviews for the American Masters series on PBS. You know, it's like it was our series. And he kept saying, because he goes in and out a little bit. He's like, I'm gonna have a press conference and set them straight. I'm gonna call the New York Times. I mean, they're not gonna come, dude. You know, but in this interview, and on January 19, 2019, they asked him about those comments, like this person, and he said, "Yeah, I still believe that." So he's unrepentant, you know. And he said a few choice things about African Americans and Jews when I was in his presence, and he has. I've known him a long time. He said so. He got hoisted by his own petard eventually, and he did it one time too many, and finally, society is saying no, can't do that.
A related question about the anti-Semitism, what happened to Rosalyn Franklin, was common among Jewish scientists at the time, or more so because she was a woman, or the confluence of both gender and anti-Semitism?
You know, it's hard to measure if it was like, you know, a 50 for her and a 25 for somebody who just had one of them, you know, or something like that. Certainly being Jewish in Great Britain was hard, particularly if you wanted to go to university and advance in so many businesses and industries. And being a woman, I mean, women couldn't own property. Women didn't. Women just got the voting right, you know, maybe 20 years earlier, 30 years earlier. There are all sorts. There are only 500 spots for women at Cambridge, but 5,000 for men, or things like that. You know, I mean, read Virginia Woolf, particularly a room of one, or a room of one's own, where she said, we look at things with the same eyes, but we see it differently. So if you're a man, you saw it very differently than you're a woman. So both worked against her, and her personality worked against her. But as I said, if she were a guy, they just would have probably, you know, she's just that way, or he is just that way.
Right. That last question was from Christina Finn. I want to give her credit. And the next question is a next segue from what you just said about being a man or being a woman. And it says here, Crick and Watson clearly felt they were in a race to discover the structure of DNA, but it's much less clear that Roslyn felt that she was in that same race. Do you think she was interested in the race? Was she?
No, I think you're right. That's a very astute point.
Cleo Franklin, yeah, thank you.
Cleo, well, first of all, Cleo, what she was doing was building step by step, like a giant house of cards. It's hard to do, but when it's all done, you can look at it, and then you can say with at least some authority, it looks like this. These guys wanted to skip all those steps and then work backwards. Okay, so now I forgot the question.
The kind of race she was in.
So so Watson was in a race. Watson was in a race from the day he was born, okay? And he got Crick all revved up too. Wilkins was kind of slow, and he was kind of waiting for Rosalind to go. Then he could be free. As he said, we'll put all hands to the pumps end. Unfortunately, the day he wrote that letter, Watson and Crick had completed their model. But she wasn't in the race because she knew there were a million data points that had to be discovered. And that was the type of scientist she was. And it's funny, today, that's the kind of scientist you want. But theoretical physicists were sort of the surgeons of the scientific community. You know, they were swashbucklers and people admired them and stuff. And then the people who did the data were the drudges. So even Francis Crick said, you know, we were always kind of, we always kind of sneered and were condescending to Roslyn. He admitted it. And he also said she would have figured it out in a few weeks.
Amazing.
But Wilkins would not have, he said.
Nicole, do you have questions? I want to ask if you have any questions, or as an archivist, do you have any reflections on Howard's Odyssey here? And you're on mute.
No, I'm sorry. I can hear my child crying in the background, so I apologize for that. No, I think it's interesting, your perspective in using different archives, and from an archivist point of view, the level of accessibility in obtaining the records that you obtain. You mentioned getting into the Nobel Prize archives and the challenges, because this is really viewed as sort of an internal archive in many ways and not as public facing as perhaps some of the other ones. I would say in terms of archival questions.
But essential nonetheless. If I had not gotten in there, it would not have been the same book, you know?
Absolutely. I would say as a historian and a practicing clinician, what would you convey to other perhaps physicians about the importance of archives in doing this kind of research and the value in the history of science to current practice? So it's a little off topic, but I'd be interested to hear your perspective.
Yeah, I mean, the archives are the laboratory of the historian. Libraries too, if you, unlike our medical library no longer has books, but that's another story. But yeah, I mean, that's where you find, now, it's not a perfect laboratory because it depends on what's been saved. And like for now, nobody's saving their letters because they don't write letters, they write email, but that has to be
Right.
saved. So it can be, history can be slanted like in a time bomb, like you're leaving these papers for some future historian to find, but it completely changes the story and maybe it's false, you know what I mean? But nonetheless, it's the primary sources are essential to a professional historian, because I'm a narrative historian, so I always have been, I always want to, I love storytelling, but I knew that there has to be a rigor and a methodology to it as well. And you know, Nicole, the great way to figure out the methodology of historical book is look at the back at the references and see, are they primary sources or is it citing somebody else's work or something else? You know, I was looking at something today, it's like, that's a perfect quote. And then I looked up in the back, it was said like 80 years later. It was too perfect to be true. I mean, it was true, but it was, you know, a long time later. So yeah, I mean, and the thing about archivists is that this is for a beginning historian of medicine, be nice to the archivists and librarians because they know the collection far better than you do. And if you're nice to them, they'll tell you stuff. I've never met an archivist who didn't help me.
That's a great point. And I see one of the questions as well from an attendee about kind of who writes the history, right? And bringing it back to Hamilton, which you referenced earlier, who lives, who dies, who tells your story, right? That's part of this. Oh, yeah.
Right. It is that. It is that. Exactly. And how plastic, fluid history can be. And, you know, if you're about Joe and my age, I keep saying how old you are, but, you know, and you read that book when you were like 15, 16, 17, 18, it was a funny, and you're a boy, okay, from the 70s. It was funny. It was, you know, did you read it, Joe?
Yeah, yeah.
I mean, everybody read it and it was exciting. And I swear to God, I'm not exaggerating. When I did bench work, I thought of Watson and Crick and wondered, gee, would I be one of those people?
So Howard, I have a related final question, and it's about what motivated you and what motivated. There are two questions here about motivation, and one is why do you think, and how experience motivates people. Why do you think Watson became interested in doing research on schizophrenia as he grew older? And the second question about that was from David Wolf, and the first one was from Elihu Sussman. What motivated Franklin to become a scientist? Because it sounds like she wasn't from a scientific family. So what about the motivations?
Okay, two good questions. By the way, initially Watson wanted to be an ornithologist because his dad was an expert bird watcher. He changed, or he became interested in schizophrenia later on because his oldest son Rufus has schizophrenia, and I met him, and he's about mid-50s, but he has real issues going on, and that's been a struggle for the family their whole lives. Yeah, so he lives with his mom and dad right now. Rosalind came from a banker's family, right? And initially her dad did not understand her going into science and thought that, particularly during wartime, she would be better suited to rolling bandages and, you know, making tea. And they got in a big fight over that. But her mom is wonderful. And her letters were wonderful too, by the way. But her mom introduced her to photography when she was like 7 or 8. And you remember if you did photography when you were a kid with all the chemicals and developer, this really was really a dark room. It was really fun stuff. And she said, oh, I love this. It makes me feel all squidgy inside. And in a way that really marked the rest of her career. She was in essence a photographer of infinitesimal subjects. But on top of that, had to know the math and be able to do it basically on an abacus or a slide rule, because there's no computer to figure that stuff out. So she just loved she loved physical science, by the way, physics, chemistry, physics, not biology. That wasn't her thing. Well, and that may have held her back, by the way, in thinking about DNA as a biological molecule.
Well, the book is called The Secret of Life. Our guest has been Howard Markel, and you've really done a great job, and I think it'll make a great Christmas gift, Hanukkah gift, Kwanzaa gift, or just a secular gift for whoever's interested. And I think it's destined.
It's the gift that keeps on giving. Yeah.
Probably for you, yes, but.
For me, yeah.
Well, thank you, Howard. And
Likewise.
Nicole, our next event is, just to remind everybody.
Our next event is in March, so I'll be sending an email out with registration information to anyone who wants to attend, and we would encourage you to join us.
Okay, thank you very much and good night to everybody.
Thanks.
Good night.
Nice to see you, Joe. Thanks, Nicole.
Thank you, Howard. Great.
Thank
job.
you.
Now to get out, doesn't leave. There you go.